Hello everyone, today we're looking at the topic of solving algebraic fractions, which is key to the question on the left-hand side. And for this, we need to have prior knowledge of solving equations with fractions normally, and also the knowledge of factorizing and solving quadratics. Now, the equation I have on the right-hand side, or the question I have on the right-hand side, is one of my questions from a previous example, and it followed a step where we had algebraic terms with fractions involved within them. In this case, we've got a fraction which has a denominator of 4, another fraction with a denominator of 3. And the methodology we said is it's always easier to work with questions which don't have fractions in. So when you've got an equation, you can multiply both sides of the equation by the denominator to get rid of the fraction. If you multiply 5x over 4 by 4, it simply becomes 5x because the 4 will cancel out with the numerator. Now you have to multiply every single term on this side by 4 and every single term on this side by 4. So this becomes 5x minus 8 is equal to 4x divided by 3 plus 9 over 36, plus 36, sorry. Now, that's gotten rid of one fraction. We also need to get rid of the other fraction, which means we need to multiply every term by 3. So over here, 5x becomes 15x, 8 becomes 24, 4x over 3 becomes just 4x because the 3's cancel out, and 36 times 3 gives us 108. We've now got an equation where we just have unknowns on both sides, so we eliminate the smaller unknown by subtracting 4x from both sides. That gives us 11x minus 24 is equal to 108. We've eliminated the 4x from this side. And then from there, we simply rearrange to make x a subject by adding 24 to both sides and finally dividing by 11, giving us a value of x is equal to 12. But the key thing I want us to take away from this example on the right is that when you have fractions, you need to multiply both sides by the denominator to get rid of the fraction to make the question easier for yourself. It's much easier to solve a question when there aren't fractions involved. So if we look at the question on the left-hand side now, I have x plus 5 is equal to 3 over x plus 3. Now we've said the first step is to multiply both sides of the fraction, or both sides of the equation, by the denominator. So the denominator in this case is x plus 3. So if I multiply this side by x plus 3, or both sides by x plus 3, I'm going to put that x plus 3 in a bracket, and the same thing over here times by x plus 3, because actually this denominator is inside a bracket as well. Now, if I times x by x plus 3 and 5 by x plus 3, I can actually write this as x plus 5 all multiplied by x plus 3, and that is equal to just 3 on the right hand side, because when I multiply this by this, I get 3x plus 3 over x plus 3, and those x plus 3's will cancel out. So I've now got a question where I need to expand a double bracket. If I'm expanding a double bracket, x times x gives me x squared, x times plus 3 gives me plus 3x, 5 times x gives me plus 5x, and 5 times 3 gives me plus 15, and that is still equal to 3. Now, what we've obtained here is a quadratic term, and when you solve a quadratic, it needs to be equal to 0. This is always the case when you solve a quadratic. If we collect the like terms on the left-hand side, we have here 3x plus 5x, giving us x squared plus 8x plus 15 is equal to 3. Now we said we need to solve this quadratic. It needs to be equal to 0. So I need to bring this 3 to this side, or I need to subtract 3 from both sides. If I subtract 3 from here and subtract 3 from here, I get x squared plus 8x plus 12 is equal to 0. Now, to solve a quadratic, you can either factorize or use the quadratic formula. If we want to factorize, we need to find two numbers that multiply to make 12 and add to make 8. Our numbers that multiply to make 12 are 1 and 12, or 2 and 6, or 3 and 4. 2 and 6 add to make 12, I add to make 8. So our solutions or our factors here are x plus 2 and x plus 6 is equal to 0. And when we solve a quadratic, we simply equate each of these to 0. So if we are saying x plus 2 is equal to 0, very simply x is equal to minus 2. And if we solve x plus 6 is equal to 0, x is equal to minus 6. And that's the process, and that is exactly the same process we're going to apply for all these questions. You first multiply through by the denominator, you then expand your double bracket or expand the brackets that come about, and because we've obtained a quadratic, when you solve a quadratic, it must be equal to 0, and we can then, as we said, either factorize or use the quadratic formula to solve. We're going to look at 2 more examples of this and just apply the same principles to this. So the first example we're going to look at is 2x over 3 minus x is equal to 1 over x plus 2. Now the first thing we notice here is we actually have 2 denominators. I've got a denominator on the left hand side of 3 minus x and the denominator on the right hand side of x plus 2. So if I multiply both sides by this denominator of 3 minus x, so times by 3 minus x, and times this side by 3 minus x, I'm going to get this denominator over here to cancel out. That's going to give me just 2x is equal to 1 over, sorry, not 1, because I've multiplied this side by 3 minus x, 3 minus x over x plus 2. Now I've got a question that looks very, very similar to this one. So I now need to multiply both sides by x plus 2 to get rid of this denominator. So times by x plus 2 and times by x plus 2 gives me 2x brackets x plus 2 is equal to 3 minus x, because once again this x plus 2 will be on the numerator and it will cancel out with this x plus 2, which is, as we said, also inside these brackets. Now we're in the same scenario we were before. We need to expand our double bracket out. When we expand the double bracket, we end up with 2x times x is 2x squared, 2x plus 2, or 2x times by plus 2 is plus 4x, is equal to 3 minus x. We've now expanded our double bracket and we've got an equation, but when we want to solve this, again, we've got a quadratic term, so we need to solve this by making it equal to 0. So for this, I'm going to add x to both sides because I've got a minus x over here. So I'm going to add x to both sides and add x. And I'm also going to subtract 3 from this side and subtract 3 from this side. That is going to give me 2x squared. The 4x plus the x makes plus 5x. And then I've got minus 3. There's nothing here, so that's simply minus 3 is equal to 0. We now have a quadratic that we can either factorize or use the quadratic formula for. Now, normally we would use the AC method here. AC is equal to 2 times by minus 3, which is minus 6. And we need 2 numbers that multiply to make minus 6 and add to make 5. Well, that is going to be minus 1 and 6. Minus 1 plus 6 adds to make 5x. So if we do this via our process we've done before, that's going to be 2x squared minus x plus 6x minus 3 is equal to 0. We can now factorize these out in our pairs, giving us a factor of x brackets 2x minus 1 plus 3 brackets 2x minus 1 is equal to 0. We now have a common factor of 2x minus 1 brackets x plus 3 is equal to 0. And our final step here is now just to work out the values of x by equating these equations or these portions to 0. That's going to be 2x minus 1 equals 0 and x plus 3 is equal to 0. Therefore, x here is equal to minus 3. And over here, we're going to get, if we take the 1 over 2x is equal to 1, and x is equal to a half. And those are our two solutions. Again, we once again follow the same process. We first multiplied through by not just one denominator, but by both denominators. And those denominators cancelled out. We then expanded the double bracket that was created and formed a quadratic. We equated that quadratic to 0, and then we solved via factorising. So we've seen two examples here which have been able to solve via factorising. One which is an x squared quadratic where the coefficient of x squared is 1, one where it has an x squared coefficient equal to a value which is not equal to 1. And we're going to now look at one final scenario where we're not going to be able to factorise, so it means we're probably going to have to use the quadratic formula, and that I'm going to show you over here. This is our final example. 6 over x minus 1 plus 2 over x plus 1 is equal to 3. Now, we're going to multiply through by our denominators first. This first denominator is x minus 1. That's going to give me 6 plus 2x minus 1 over x plus 1 is equal to 3x minus 1. That's multiplying through everything by x minus 1. We then need to multiply through everything by x plus 1. So we're going to get 6 brackets x plus 1 plus 2 brackets x minus 1 is equal to 3 brackets x minus 1 and x plus 1. That there has gotten rid of our fractions. So we now need to expand our brackets and solve accordingly. If we expand our brackets, we get 6x plus 6 plus 2x minus 2 is equal to, if we expand the double brackets first, 3 brackets x squared minus x plus x minus 1. And we can see actually here, this minus x plus x is going to cancel out because this is the difference of two squares or dots. That means over here, I'm going to have 3 brackets x squared minus 1. So we've got 6x plus 2x over here is actually going to make 8x if we collect the like terms. And 6 minus 2 gives us plus 4. So we now just simply need to expand our bracket on the right and then equate our equation to 0. So from that we get 3x squared minus 3 is equal to 8x plus 4. And then we bring all the terms to the right hand side to keep the x squared positive, giving us 3x squared minus 8x minus 7 is equal to 0. So we have a quadratic here, and we are going to try and factorize this via the AC method. If we use the AC method, a times c, 3 and minus 7 is minus 21. The only values that multiply to make minus 21 are 1 and minus 21, minus 1 and 21, 3 and minus 7 and 3. Now, none of these combinations add to make minus 8x. Therefore, we have to use the quadratic formula. Now, the quadratic formula is as seen over here. X equals minus b plus or minus square root b squared minus 4ac all over 2a. And for this, we need the values of a, b, and c. A is equal to 3, b is equal to minus 8, so a is equal to 3, b is equal to minus 8, c is equal to minus 7, and if we substitute those values into the formula above, we get the following two values. X equals 3.36 and x equals minus 0.694. Now, I haven't gone through this in full detail, but it just follows the same process. As we've seen previously, we multiply through by the denominators, expand our brackets, create our quadratic, and then solve.